Thank you. Um, Sorry. Thank you so much, Guy, for this incredible introduction. It's a very sort of, it's with a lot of emotion that I'll be standing in front of you here today because this is, in a form, a homecoming for me. After quite a few years since I left almost 13 years now. And I'm really grateful that I'm able to be here at the GSA. It's actually my first time at the GSA too, and get to witness the pedagogy here, engaging with the students. So, what I want to do in presenting my work today is to speak to the journey a little bit of to speak a little bit to my journey, but also to mostly talk about the work that I do at Worofila, my practice that is based in Dakar, Senegal, and what just speak to our preoccupation with really developing a practice that makes sense for the place that we're operating from, because it really is a place that has taught me a lot, and that is really allowed me to kind of like grow and really kind of like affect my environment and be of service, let's say, to my both local and international community. So that's what I really want to share with you today. Uh, Very, very short. I mean, you've heard my bio now, but I still felt that it was important to kind of talk a little bit about where I sort of have come from. So I'm a baby born in Southern Africa, particularly Maputo, Mozambique. It's a place that has impacted me a lot, particularly the city center, with its colonial architecture, but also modernist architecture. And I moved to South Africa when I was 13, and I got a chance to study at the University of Pretoria. And I would just say this, is that I always felt, particularly studying the context of South Africa, that it was important to engage with the kind of like social, cultural dimension of architecture. And I would also say that Pretoria definitely gave me some understanding of regional modernism and bioclimatic design. Then I got encouraged heavily by one of my tutors to go work at or apply to work at 26 and South Architects. Sorry, it's this outdated photo, Torsten. But it may not be fair, like the full team, this is from years ago. But I just do want to say something about how this practice impacted me, because it really taught me how research in architecture was possible. And there is something about the name as well, and kind of being very local to Johannesburg and to your context, that I really appreciated a lot working there. Then also, this was a defining moment for me, this exhibition, because it enabled me to kind of really center the African city. I know for students today at the GSA, it seems like a given. But if you think about the rest of the continent, a lot of the discourse of architecture didn't really speak about modern or contemporary architecture. And this exhibition that was done by David Adjaye back then really shifted that perspective, and didn't really bring me to London. But I got a chance to study at the University of Westminster. My second year was under the leadership of Professor Lindsay Bremner. So South Africa sort of met me again in London, which was a really life savior, because I learned so much from her and her sort of, very sort of unique kind of understanding of the Anthropocene as well, which was the subject of my final year thesis. And it made me think a little bit deeply about the importance or the kind of weight of fossil resources, so whether it's material or energy, right, like oil and gas that we use so much in the field of construction. I then went on to work at GSA Associates in London. And I got to work on very corporate projects, actually, working for big banks. One project was in London. And then the other project was actually Dakar. The project you see to your right is the headquarters of the IFC. And that is, in a way, is the project that prepared my transition to return back to my fatherland of Senegal. And this was, the kind of like bricks that were produced or the brick samples that were produced in that building. And through that project, I got a chance to meet a really incredible Senegalese engineer called Didi Vem. who had come back to Senegal nearly 6 years prior to me and set up this company that was producing earth bricks. And through him, I got to meet many other architects and we formed a collective. We met on this particular street called Worofila. We didn't know that we were going to name ourselves that, but I had a little bit of inspiration from another practice that named itself through, its territoriality. So when it came time to name ourselves, we just, picked the name of the street where we are in Senegal. So that's what is behind Worofila, which actually means seven. So we're on Street 7. It's very inventive, but it was very important, jokes aside, that we are able to really be informed by our context, but also learn how to respond to it in a responsible manner. So on this note, Dakar is the most western city on the African continent. It sits on the peninsula, which is the peninsula of the Green Cape of the Cabo Verde, the archipelago islands just off the coast. But, our peninsula was also made like that by the Portuguese explorer because of how green it used to be. Fast forward to today, this is an aerial satellite imagery of the peninsula, which has taken a very distinctive gray color, which is really a sort of manifestation of the presence of concrete as a main material that sort of produces the city. It's also important to say that in recent decades, a lot of the city has been produced by people themselves, and concrete or cement is really the material of empowerment, right? Because in the context where a lot of failures from the state have operated, people have taken it onto themselves to really produce housing, and it's really done through the cement, because cement is so for context, Senegal also produces cement. It's our 5th largest export. The cement is ubiquitous. You can buy it at any hardware store. And I think it just gives this kind of ability for facility to, want to buy a bag of cement. If you have a little bit of water and sand, you can start to produce your masonry blocks. And usually the pattern of kind of building is to get land acquisition. And then the first thing, once you have a little bit money, you buy some bags of cement, you produce the bricks, you sometimes leave them on site, and you kind of build incrementally. And when we look a little bit at the geography of production of concrete, which is the main material, it's the lot of these cement factories actually within, I would say, about 100 kilometers from Dakar. Most of them sit within even the region of Dakar, and many of the extraction sites for basalt that is used as aggregates, the place of production of steel or recycling of steel in Senegal as well is actually within the region. So we're kind of talking about ecologies that are really in close proximity to the capital. And I think it's important to kind of take also a closer look and never think about materials to not sort of dissociate them from the sites where the sort of raw materials sort of come from, because they have certain realities. There are certain disturbances as well of the environment. The top picture is a classic pine forest, which is a game, not far from Dakar. And a lot of the baobabs, so the forest had a lot of baobabs are being knocked over because underneath it you have limestone. And I think, again, even just when we look at segmenting itself, there's something about this composition and that I think needs to be recentered, which is the fact that it comes from a lot of these sort of natural geogenic materials, because cement is also made with lime. So a lot of this extraction of limestone is that it produce cement of sand and also clay. A lot of the clay qualities that they have nowadays are actually bought by cement factories. And it's interesting to look at the ingredients of cement in relation to the kind of architecture and very rich sort of architectural language that they were able to produce in the past. I think when we look at different epochs of Senegalese architecture, we do see a very sort of inventive use of clay, of fiber, of stone, of ceramics even, or shells as well, which often get used as well to produce a form of lye. So this is the context in which we feel that biothematic architecture can becomes an interesting response to this sort of over concretization of the landscape, because with the complete comes and the way that it's utilized, there's a lot of thermal discomfort as well that is generated in the interiors, but at the cityscape as well, because as a peninsula, people also densify. And I just want to speak to you a little bit through the sort of methodology and the way in which bioclimatic architecture is also tied to traditions, architectural traditions. Our first vantage point is really to look at the climate. And this is a sort of interpretation of the Copenhagen climatic map, understanding the continent through its climatic zones. Most of Senegal sits actually within the region commonly known as the Sahel, that goes from Dakar to Djibouti on the Red Sea. And we sit mostly in a sort of hot and arid climate, with a little bit more of a humid zone to the south. When we kind of look at the various stratification, the north, it gets very desertic because we're nearing the Sahara Desert, and the south is a lot more humid. See the unique shape of the country that sort of surrounds the country of Gambia. But when we look at the sort of like rainfall patterns as well, particularly in the south, we see really big differences of it. Like in the north, we have like really less than 300 millimeters of rain. In the south, and but more. And the southern region, called Casamance, has a really rich architecture. I mean, a really rich and lush landscape. I say this as somebody coming from Dakar, but I think also a very unique architecture that really speaks a lot to its climate. One of the most unique architectural typologies of the South, are the Biegueng houses, which are actually indicators, I think, of the geography which they sit in. And I would say that of any form of vernacular architecture or traditional architecture, I think the learnings from it are actually quite incredible, because they always tell us, or they give us cues on how to respond to a particular geography. So I first kind of engaged with the materials, obviously, that we had there, but most importantly, to respond to the time. And so by kind of even looking at this picture, you understand that this is a place that raised a lot because of the kind of structure of the roof, and as an improvement suggests, is really a sort of response to rain, to be able to kind of gather it. And I'd added the picture at the bottom to kind of speak to the fact that even though these are traditional typologies, this shows a picture on the bottom of his site, of a construction site, in 2021, of somebody that was doing a B&B. It was like a 30-something old man. He was building a place for people to kind of be able to spend the night. And he did so using this ancestral technique that you can see that, the kind of like shaping, the can is a little bit different than the circular can. Nevertheless, I think sort of this very simple diagrammings are important to kind of showcase what is it that we can learn from this traditional typology. And with the Kruger, I think, or even just in Kruger House, it's important to see how it's really shelled up from the outside, and it's really orchestrated around the sort of like central courtyard and atrium, which is really the main source of sunlight. The collection of pond of the rainwater helps a lot as well to cool the air through the and the sort of detachment of the roof, or the thatch roofing over the earthen walls as well, is really a strategy that sort of is really valuable in terms of providing ventilation, evacuative cooling, but also the thermal inertia that these sort of thick earthen walls confer. And this is a good way to speak, after learning those principles, to speak to you about one of our key projects, which is this vertical house in Dakar. This is a project that we completed about 2 years ago. And this was a very important project, because they had to find a way to actually produce housing in the city where the land parcel was actually quite tight. The plots are 150 square meters. And the brief was to produce an earthen home, but in a very sort of dense urban environment. And that kind of forced us to look at how to achieve a certain level of verticalization, but also of passive design methodology, right? So that this house would not require any type of AC or heating, I guess, for thermal comfort. So the house and the massing strategy is because we managed to actually respect the urban planning laws, which unfortunately in Dakar is quite exceptional, and which sort of requires you to build on the maximum of 70% of the land. So the first thing that was done was to think about creating these kind of atria, about 3 of them, which I'll show you are useful for ventilation and lighting purposes. And then also be able to have setbacks from the third floor in order to allow for rights of light and not have this sort of big block that kind of prevents any light access to the neighbors. This is how it sits within the environment. So which is for you to just understand, and going back to that kind of image of the concrete city, this is the project in relation to its urban setting. And this sort of comparative diagram often showcase the ways in which the sort of atrium, particularly central atrium, that actually features a pool, is able to kind of play a role of and contribute to cooling through the evaporative cooling strategy, the same way as with the premium houses. We also managed through this sort of carving out to ensure that most roofs have a forced ventilation as well. And ensure that as well through these various atrias that we're able to get some amount of light in addition to the sort of main street facade that they have. And other strategies were kind of integrated into the facade to provide a cooling, which also speaks to the materiality of the project, which is made with these compressed earth blocks. And we found a way to kind of have this sort of facade system that allows for shading on part of the wall for particularly the we're in the northern hemisphere, so the southern sun, which is, the one problem about like midday, which is at, really hot. So yeah, this is a small strategy that we develop and use in multiple other projects. Some think it like just closer look at the detailing of it, because of when you work with bricks, and this is a load bearing also brick project, although there are some column reinforcement which we did in order to just reduce the thickness of the wall. You have to be very intentional about how you case the bricks, right? I mean, I don't have to spook people in South Africa about brick design because it's very ubiquitous here. But yes, this is something that we've taken to task. And I think we also learned how to play with it in order to produce a very distinctive materiality that actually speaks to the kind of composition of the wall and is able to do multiple days. And yes, lots of detailings around openings as well, because we're working with emulsion material in order to ensure that we prevent any type of kind of light offcuts and really have the sort of unique of the brick determine the composition of the facade. And the final kind of finish as well is really the raw color of the earth, which especially in the exterior. Number one, I think it's important that the communicator convey that what the building is made of, but it's also that we live in a very sort of in a context where there's a lot of sandy winds as well, and I think that rather than paint made or having a light color, this is something that is actually that sustains this sort of like very sandy air quite well. Shifting a little bit to the, I guess, east, the same within West Africa. Another territory where we've gotten the opportunity to work with, actually first work outside of Senegal, is in Nigeria, which again, when we look at it from a sort of regional climatic perspective, also historical perspective, it's interesting to see the kind of commonalities that exist with Senegal. And I'm going to draw onto those comparisons quite a lot, because as an architect coming from Senegal and trying to really learn from the space, right, from the place particularly, in some of the traditions, you always wonder, if you don't know about a certain place, how can you design for it? So it's interesting to kind of see how the baggage that we hold from that region can travel, and how we find also echoes in a context like Nigeria. So the project that we got to do is part of the larger campus of the Museum of West African Art. It's in the city of Benin, the historical city of Benin. And we got commissioned to build the Rainforest Gallery, a gallery for art that was meant to sit in this precinct that also was meant to have a museum, a boutique hotel, a pavilion for archaeological research. And our project sits within also a repotted rainforest, which was also seen as part of a restoration effort in a place that has lost a lot of this natural kind of ecosystem. Benin is known for the very ancient kingdom, and the ancient city of Benin used to have this like impressive earth moat walls, which had disappeared mostly in the city, but there's some remnants where you can see just how big they are and really how thick. I mean, these are like, fortresses, because this was defensive infrastructure, but these were made using earth, and in the same distinctive sort of red laterite color that we have in Senegal. You may recognize the person to the right of this picture. That was also involved in the field trip on the project, and we were able to be on field trips and look at the kind of traditional architecture of the city, and particularly the royal architecture that was made with this earth with very unique materialities. I guess the one to the left is a little bit more raw, but the one to the right really speaks about a particular technique which is very unique to Benin. So to draw again these parallels, so you look at on the left the sort of wall to Benin, the one of sort of palace, not palace, house of a noble person, Ogamen's house, and the right you have the walls from Casamance in Senegal, and both of them are constructed using the technique of cob, which I'll speak to a little bit later. So it's we already had a certain degree of familiarity with this technique once we arrived in Nigeria. Another thing as well about these walls, there's this one horizontal kind of like texture that you see, which is called fleeting, is a technique which actually allows for a control of the erosion of the walls through water. So it's sort of by scoring the walls, you kind of slow down the way that water percolates through it. So it is a form of erosion control. But it was also something that was only made in kind of this royal architecture because it also demarcated status. Another funny anecdote as well, I'll speak about it later, but the NKD house as well, the vertical house, has, I think, a similar kind of like texture through the wall, even though this was not thought as a form of erosion control. But again, we recognize that in certain language in the architecture. And these are the remnants of the original, palace of the Oba, so the king of Benin. This is a historical picture. I think just straight after the fire, there was a punitive expedition by the British in 1897 that sort of burned the palace almost to the ground, and a lot of the artifacts were looted. We may have heard about the green bronzes, which are really at the heart of a lot of the conversation around destitution, because it's one of the most evidently documented case of looting. Yet there's an argument as to whether it should be returned or not. But yeah, the campus also, I think, was the project that was generated out of this kind of out of the conversations that have been held around it. But yes, also the anecdote that I wanted to share when in us researching and understanding his royal architecture and palace architecture is that the cob wall layers, because it's built in layers, actually had names, and you could have I think up to like 6. So you have the foundation a layer that had a name, and all the various layers, and of course it's only like the king that to have the biggest amount of layers. But I found it incredible that it was like a language to sort of codify a construction technique, which is very precious to us. So the design of the Rainforest Gallery draws a lot of cues from this, from a lot of this traditional architecture. For us, it was also a way to kind of respond again mostly to the climate and this new environment of the rainforest that will be generated around it. Rainforest, again, this is a map of the kind of loss of forestation in red that you can see in the context of the main city. The type of vegetation of the place is mostly kind of, called sort of tropical, subtropical, moist broadleaf forest. That's a biome. This project is an effort to contribute to reforestation. And it's these pictures. So in the right, you see the kind of undisturbed part of the forest as it is today. And to the left, a project in another state of Nigeria, Ibadan, of a vapor 8-year-old forests and seeing a little bit the kind of quantity of that you can get, because our first worry was that, how do you design something, even though the forest can create a microclimate, how long was that going to take, in order for this environment to have a very distinctive microclimate. Look at working with endemic trees as well as men, and making sure that the forest was also had spaces for art that would actually complement whatever is happening inside the gallery. So allowing really the visitors to inhabit this space. And that really guided a lot of our strategies for the design of this. It's really composed in two spaces. You have the sort of like current exhibition space, which is smaller, and the temporary exhibition space. And our desire for this, and the tours are separated by a vestibule. And our desire for this was to make sure that people could also inhabit the kind of like envelope of a building. So if you are in res, is if you are sort of like, public, that isn't necessarily going to the gallery, you can have some interaction with the building, and you can visit of the gallery as well. You're able to kind of have a kind of pop-up that allows you to personally engage with the envelope of the building. And in terms of the sort of strategy, so generative type and strategy for this, it was very much guided by wanting to create a kind of microclimate in the gallery. We had some requirements for certain kind of like temperature that we had to achieve, which are actually quite low given the temperatures of Benin. It was about like 20 degrees, but this is what was set for international standards, and 50% relative humidity. So questions of climate control and the passive design strategy, even if the building would definitely require some level of air conditioning, we still wanted the architecture to contribute to lessening the load and necessity or reliance, at least on technology for cooling. So one of the strategies was a series of strategies essentially that set in place. One is the box in the box, which is really effective for acoustic control, but also for thermal control to have a space enclosed into another one. The sequencing as well was really key, because we felt there was maybe an urge, or a kind of, not urge, but maybe potential disposition to think that, you're going to have this forest, you're doing a gallery, you can have this very open glass box, which we felt that this kind of level of openness and transparency doesn't sit very well with kind of cultural understanding of space. Threshold is really important. How you approach a place, how it deals itself as well, is something that is really key. So we did that through this idea of the succession of the walls as well, which when you look at it in section, allows us to have multiple layers, this kind of a double skin, which with very thick earthen walls also attributes to kind of having really good thermal resistance. And then the roof play a really important part in kind of ensuring that it had an insulated roof, and also prevented any kind of direct light into the space. Drawing again on parallels between the sort of the vernacular architecture of Benin and the one of southern Senegal. A lot of the royal architecture also features this kind of diffusion. It's and the central lighting is something that we see in both architecture. And we drew onto that to actually devise the space of the gallery. So we have this sort of inverted roof, which kind of allows for kind of central connection of green water. And then we've actually lowered the middle space, the sort of box in the box, because it allows us to have two aisles and two spaces that are indirectly lit. So we have, darker room in the middle, and then the mid stays on the periphery, and then the external buffer walls, which also allow for us to sort of contain a layer of vegetation, are able to also, give this two things. I think one, increase the thermal resistance, but also allow for vegetation to come also in close contact to the spaces that are inhabited in the building, because of the power that it has to provide get passive cooling through evapotranspiration. And earthen walls as well, because they are raw, have a potential for moisture absorption, which is actually, I think, one of the biggest sort of property, which contributes greatly to thermal comfort, because especially in like very high humidity environment, you want materials that are going to be able to absorb that humidity, and get with a lessened humidity, feel cooler or a little bit more comfortable. This is a render which was actually produced by our collaborators and local architects through your contract. I know that Raifa was here a few years back giving a lecture, they help. They also are designing another project on the MOWAA campus, but the collaboration on this project was really valuable. They gave us a lot of also license to explore certain things that we couldn't do the set in Senegal, like having this like massive timber truss, which we will find a way to execute. But it's indeed great working with them on this project. So the other component to it, you've heard me speak a lot about the sort of material properties that it's very important for us to be working with biogenic and geogenic materials. And we developed a sort of set of solutions for them, which I'm going to illustrate to you through a series of projects, but also talk a little bit about their processes and how they're anchored into the territory of Senegal. So going back again to this sort of dichotomy between what is common case construction with cement and the sustainable construction, which in our definition also goes it allows you to centrist bioclimatic and passive design methodologies that I've explained previously, but also utilizes these materials. We are now at a case where we are trying to think very and intentionally about how to construct a typical building and all its various components in order to be able to reclaim them. So it's actually not just the envelope. There's a growing affection around just even and like all the energy is like electricity. When do we really need it? Are there alternative ways to fuel cell electricity? And also think about plumbing and elements in the windows in relation to our climate. So this is a bit of a toolkit of the kind of alternative solutions that we've developed to very conventional building practices, which utilizes these natural materials and different construction systems as well. And for that, we also have to be informed by the materials that are available locally as well. We are based in Dakar, so even though we have projects, more and more projects in other regions, but our immediate context of operation is close to the Dakar region, to the capital, which is a place that has a lot of laterite. Laterite is very distinctive, sort of Greek birth. Is quite unique in its composition because it does have just the right amount of clayey sands, gravel, silt in almost sort of equal proportion, which makes it a really good proponent for rammed earth. Or if you think about rammed earth in a mechanic, in a sort of industrial way and at a smaller scale, you have this technique called compressed and stabilized earth blocks. Which is the other using machine. This is a manual machine. There's so many open source CADs for how to produce a mold. So this is a version, but there are much simpler molds for it. They're very popular in places like India as well. It's not a traditional technique because just because of the machinery used, but also the stabilization, which is actually done either lime or cement at a very small amount, about 3 to 8%. Of course, kind of like negates the sort of traditional aspect to it. So I think it's important just for you to understand the distinction. I've shown you projects made out of CSCDs, but as we go forward, it's something that we also are questioning nowadays. But in the early days of our practice, and also because as I explained to you, we exist because of this engineer who produces these bricks in this factory, which we have access to. And it's great to have access to places of making because you're able to engage with the process in a very inventive way. And the first thing that I did when I went to the factory was to see the various type of, like the laterite being there, but lime sand as well, and thinking and testing, various compositions to see the kind of, various outputs that could come out of it. And these are on the this is bricks for my first project in Senegal that were ordered at Doudou's factory at Dédémentaire. And to the right and delivered on site, and to the right you have the sort of dry stacking of all these bricks, which has to be done also coordination purposes. But this is a little tip in kind of like site management as well. Nobody cares about the drawings. He looks at it. the tolerance of the drawing is not the tolerance of sight. So you have to make sure that things, still fit. And dry stacking is a good exercise to ensure that the masons understand, the importance of kind of like sagare, and that, we're able to have these type of correction before they actually are able to execute, because layers are repetitive, as each of the courses of the brick profile are detailed in separate courses. So this is something that, we do for ourselves. I've accepted that drawings is mostly for the architect, but it does allow us to have like quantities to be able to order and to be able to foresee any kind of, issues in the project. The modularity of the brick again allows for this type of organizing of the facade. This you could see how you can just build this whole facade with a unit, which is the brick. Another material that we work with is Tifa. It's an invasive plant in Senegal, which I feel like in some of the pictures, some of the students have spoken a lot about wetlands, and I wonder if I didn't spot at some point this plant. So just look out for it, because it has very big looks. And Tifa, so yeah, maybe before that, it is important for the end. It's non-endemic to Senegal. It's invasive. It's taken over, and it grows in brackish water. It's taken over a lot of sort of water bodies. It grows super, super quickly. You cut it and it regrows within weeks. The one thing about Tifa, which is quite incredible from an architectural perspective, is that it has really great insulation properties that are quite similar to hemp, and we have an abundance of it. Mostly, I think, female Tifa, when it's cut and dry, has to be properly dry. We have the ability to crush it with very simple machinery, and be able to kind of mix it with clay, which in this case, clay acts as a binder in order to produce this kind of insulating blocks that are sun-dried. But you see the process, how super low-tech it is. This is the same as kind of producing the sort of cement blocks that people use to make these sort of intermediate floors of flat roofing, which is quite common in Senegal because of our climate. It doesn't rain a lot. Sorry. And this is probably one of the technologies that I believe in the most, because of how simple it is, how it relies on a very sort of a prominent resource, but also the fact that it just allows for substitution of a technique that people use a lot. So, and I think it has the potential for one of the most important strategies in passive design, which is to insulate the roof, which is always exposed to the sun in the context like Dakar. We are able to, even though this is a sort of alternative materials, but it's very important to afterwards have the level waterproofing, and you can have it as an intermediate floor or as a sort of bio-roof slab. In the first project that I showed you a little bit before, this was also material that was used for the roofs. On the bottom right, you see this sort of teacup box, the way it's meant to be used. But throughout the course of this project, there was an issue with the machine at some point at the factory, because it stopped, the crusher was working. So the contractor is looking at these anyway, where are these sort of materials that you kind of are possibly to build with? And I said, look, I don't have it, but they seem to have at the factory in these sort of like wooden panels or Tifa that are 10 centimeters thick, which I felt should do a good job to insulate the roof. So that was a sort of substitution, which was then, covered again, which you can screed to fall. So, we see it, but it was important to make sure that all the roofs of the house had this Tifa to act as an insulating layer. Local wood as well, even though in our ecosystem we don't have as much of it. For this particular project, I chose to work with it because it's very close to the sea, and you work with kind of like metal, particularly the metal building for security just wasn't going to be sustainable because of the salt erosion. So I developed this system of openings using timber and making sure that we had openings that were secure, that were there for security, for ventilation, for lights. That forced me to have very careful consideration, of course, of how to the amount of not just the size of the openings, but the amount of the space that could open to allow for fresh air. Make sure that there's mosquito nests on the outside so that the mosquitoes' air can come in, but not the mosquitoes because of the climate that we're in. And this is sort of like the final result. Also, these openings that were done with the local carpenters as well. This is actually the carpenter right next to the office. So I was able to sort of control this thing by just sitting in my balcony and see what it's like. But that's also what is nice about our ecology is that, we have so many resources there that we can work with. It's obviously a lot more of monitoring, but I think it gives a greater sense of empowerment as well to work with that. All the exploration with the fibers that they have available was for cupboards to be able to use kind of like the woven max for as info because it's non sort of structural in the project. There's this small artisanal factory which produces ceramics still that we also work with, and it complements the raw earth construction quite well because not just is the same color, it's the same, essentially it's the same material. It's clay, it's just pine clay. So we're able to kind of use it mostly in our earlier project, mostly for kind of like, flooring outside and the inside as well, like in the vertical house. But laterites is not the only type of clay-rich soil that we have in the region of Dakar. There's many others as well. So in the red, you see the sort of laterite, but there are many other type of clays which have very distinctive colors. Remember this picture from the article that Nick showed yesterday? This is a picture actually taken outside of the ceramic factory because in order to make the ceramics, he actually mixes different types of clay-rich soils that all have different granulometry, different contents of clays. So he has this kind of like, recipe with the three different type of clays, the one that you see in the forefront. But he sits in a city, which is the city of Sibikotan, that is actually where the soil is all laterite. So at the back of it, you can see the amount of earth that's been moved because it's a new train line project that is actually moving through the city. And I just love to see the sort of juxtaposition of all the soil. And the brown one is really from within the site because he set up his factory there because the material was there. It's like the cement factories, right? He followed the geology. So working, and I think and expanding our minds to really welcome and explore what working with those various type of clay is really goes through a process of earth testing, which is very manual. And I think there's a way of kind of working with natural materials that engages the body and generates a way of knowing, which is actually quite incredible because you never forget it as well. And here you see the sort of diversity again of soils, which soils that we get that had different appearances, whether they're dry, plastic, and at the bottom you have this in Kutch it's called the cigar test. I forgot the name in English, but test in which you sort of do this kind of like tube, let's say, like with earth. You push it up the ledge of a table and you see how it breaks, and it tells you everything about the sort of clay content, whether it has like sand. And those tests actually give information about what you do with the breaks. Typically as well, one of the things that we start to look into is adobes, which are just what is commonly known as mud bricks, where a certain amount, maybe you need a little bit more clay than with the CSCB. It gets mixed with water to rest for a few days and then boil it in sun dry. And this is us documenting the process of how we work with Adobe, but it does involve sometimes some level of reinforcement with TIPA fibers as well to prevent it from cracking. We've also been able to, in recent years, if you kind of remember the sort of toolkit table, think of alternative building systems. We felt that it was important for us to develop it ourselves. I think before we had the advantage of having the proximity to this factory, which taught us a lot because Dudu is not just a manufacturer, it is also an engineer that has been trained to understand earth construction and also to build them. So he's building up the project that I showed before. But we've been able to set up this lab where we actually learn how to do things ourselves from scratch. For instance, even though we haven't done it at full scale, we'd never been able to sort of build an arch without having a kind of like, concrete beam on the side. So this kind of forces us to do a lot more research, understand techniques of Nubian vaults, for instance, and really be able to test it out, or culverting as well, to be able to generate openings through a wall. Back to the conversation on erosion. So adobes do not have any level of cement. They may have fibers, but ultimately this is just raw earth. And if you do not protect them from rain, they'll be weather. given that we were being also already working in ceramics and already had this sort of like language of the overhanging bricks with the CSB project, we tested out the wall to see what happens if you sort of put the ceramic sort of flush as inserts. Also, what happens when we kind of have them projected a little bit on the wall. This is the result at the end of the rainy season. So it's been nice to be able to kind of like, test out these various solutions and also combine various materials that they've been working with also clay posters. I swear, like the students that were working with this, so let's say the engineers and the students had came up with an intimate number combination colors. It's important to also witness the cracks and every single time write the recipe, because there are very quick ways that could be corrected. That just indicates that there's still a high clay content, and you can easily fix into adding either fiber or sand to your mix. Water and daub is also not the thing that is of interest to us. This is decay that also is quite prominent in Europe, as it is in Africa, or working because it allows us to sort of work with timber or like fiber and clay as well. Back to cob construction, this time we tried to do it with shutters to try to see if we could have this sort of very kind of like sleek walls, and also test out various composition with clay with the clay soils that we have available. Cob, this is sort of the manual for kind of shutter cob, which kind of is a little bit more cumbersome than just doing it manually, which traditionally those doesn't require any shutters. But yeah, we were happy to kind of like test it out. That also remember to develop strategies to protect the wall. So if we're going to build up this sort of low-tech system, it's important that we think as well about the kind of roofing that people can have with very cheap materials like zinc roofing, but using this kind of like T-fine clay panels underneath it to provide insulation. Although air is obviously the best insulator, so any kind of elevated roofing works as well. But yeah, these were all part of the exploration. And because we always use bird in a low bearing capacity, we although we do all these very manual and physical tests, we also do work locally labs. And you see here the prototype ball being sort of like cut into like pre-samples to bring to lab to decompression test, so that they know how we can design it and the results that they're able to get from these various sort of conformance that we develop. And also working with stone, because it's a lot of the mostly basalt have been used as aggregates, but for concrete. But there's so many other type of stone. This is a type of sandstone that that exists within the region of Dakar. So a geologist actually guided us towards that. We've tested it in its impressive strength, and also the kind of samples of foundation that we're going to go to do. And I'm showing all of this because these have become the kind of groundwork for this very important project that we have, which is the Labo. It's a training center outside of Sibirbutan. And it's a place where we think it's a sort of a place where we want people to be able to learn about eco-construction. And we've inserted it within an existing technical center. And it's a place for learning, producing, and sharing. And the design was really informed by a lot of these techniques that we sort of had developed. So to show very quickly here, there's a paste that's going to be made with Adobe and Magno posters, which is exposed on purpose because we're going to work on how to protect the poster with Arabic gum or other fine types of media biopolymers. These service towers, which is going to be done with Adobe and ceramics, and also the classroom, which is made with caulk construction and ceramics as an external layer in order to protect it from melee erosion. Our hope is that over time, this place will evolve to be a place of experimentation, to really become the place that enabled us to develop this project in a way. So continue on that tradition of being able to not just build onto the learnings, but also continue to research and experiment with various building techniques with local resource materials. Project is currently under construction, and these are the sort of Adobe production with the soil that are found on site, which is really incredible. Like, we went around the city looking for all this various laterite, but ultimately the one that we sort of excavated for the foundation is really the best profile that we use to generate the bricks. And also think at the back of the right, you have a sort of dry toilet as well that they built using local resource Tifa. And the barrack as well, the side barrack is done with Tifa by his 75-year-old man who really just weaves them and built his house out of it. So it's really, really incredible to be able to work with that. I'll finish with, my recent experience, which was a teaching in New York, where we actually found a way to export this methodology and see how it would work in a context like New York State, which obviously doesn't look like Senegal. This is a place that is highly like urbanized and known for buildings like Seagram. And I've been very interested to also rethink those buildings from a different lens. And somebody like, Kilmo through two of his projects, Unless, which is really focused in the kind of construction ecology of the Seagram diagram. You kind of can see the building in relation to sort of the amount kind of material and matter that was sort of moved in order to generate them. And there's another building which speaks about the kind of, ecologies attached to the construction of the Empire State Building. When we look also closely to this in rough architecture, we do find that a lot of it was actually produced using stone, clay, fire clay for sure. And maybe not hay, but we felt that it could be good as we were interested in working with these materials in Senegal, to also invite students to also find a way to work with these materials, but in the context of New York. And the thing about Tifa is that some of the species are actually endemic to the States and to New York. So it was a kind of nice echo and also perspective to invite them to work with this material. And another theoretical framing came from this book, which called Reciprocal Landscape, which again, going back to the pictures I was showing you of the quarry, has really done a great job of talking about the construction of New York City, of Central Park, of a bit of paving on Broadway, of so many of the infrastructure in relation to the site of extraction. We wanted the students to think about a form of reciprocity that they can have between the two by actually going to the places where these materials are actually extracted. We did field trips, found Tifa along the way, harvested it and then brought it back to the studio. The students in the first month had to do a lot of interior experimentation because all of this material were kind of new for most of them. And it was important that they engage their body and really touch the material to be able to kind of generate a level of understanding with them. And they've done really interesting proposals. Mostly, I think, it's the fact that it really taught them very basic things, like, how do you compress clay, for instance, realizing how difficult it is to be able to do something like that, or how do you, test out clay-rich soils that you've taken from dump sites in Brooklyn, and which actually contain some plastic that generates some bricks that you could use. Architecture that also tells the story of where the material sort of comes from, as this student did in her model. We also engaged stone carver, which worked on this Cathedral Parkway project in 89. And he showed us how to carve out limestone. But as he was demonstrating this, he was talking about his story and the importance of that kind of knowledge system, which we wanted the students as well to think about. This wasn't a unit that was just about natural materials. It was a really unit to think about how to reshift and have a very sort of considered methodology that is really informed by the pace, not just through climate and materials, but through the relationship to knowledge system, the way in which we use technology, the way in which, we think about, even the cycle of extraction and the kind of reciprocity that architecture can generate that. And this is one of the proposals by students, which found a way to actually break extraction site to New York City in the form of these kind of boulders that are made of Manhattan schist, and actually make not a building unbit, but as a way to allow the people that live there to inhabit case and really generate the sort of section to have a multiplicities of usage of stone, from like gabions to carved lintels to using essentially the full scope of what is produced from the extraction of it, and also be able to have this sort of quarry landscape, which becomes part of the architecture of the project. This was the final review. The students were really under pressure, but I think they found it really valuable to engage with this methodology to really reshift some of their thinking, and also the role of the architect, right? Because we had to get them to think about stuff which they felt weren't any of their business. You have the material, you think about the possibility, you'll really think about the processes, for instance, and the impact that it has even on the cycle extraction. Anyways, that's it. Just only about